Welcome pre-cal students to the homework help video. Let's go ahead and get started with number 17 through 25. The directions say to, hold on one second. Let me get my book open here to the correct page. I apologize. Okay, the directions say to construct an appropriate right triangle to complete the table. So here we go. We will use this a little later, not now. And here we go. All right, this does say the sine of 30, and first of all, they want us to write that in radians. That would be pi over 6, and then they want us to find the sine of 30. The sine of 30. Well, we're going to quickly draw a 60, 60 triangle, and then we're going to drop down this line here. We'll call this 30. We'll call this 90. We'll call this 60. We're going to call all the sides of the triangle 2, and so we know this side right here would be 2, and then of course, if we've cut this bottom side in half, then we know that, hold on one second please students, we know this side here would be a 1, and using Pythagorean's theorem we say this is the square root of 3. So the sine of 30 would be opposite over hypotenuse, which would be 1/2. Okay, moving on to number 19, we're dealing with pi over 3, which would be the same thing as 60 degrees. And so we're going to very quickly again draw a 60, 60, 60 triangle. We'll call this 2, we'll call this 2, 2, and 2, okay? And then of course if we drop a line straight down, this will become a 1, this will be 30, this will be 60, and then we'll erase this side of the triangle here. And this side over here would be square root of 3. Okay, the tangent of 60. So here's 60. Tangent is opposite over adjacent, so square root of 3 over 1, which would be square root of 3. Moving on to number 21, the secant. Now we're looking for an angle that gives us 2. Now students, think about that for a second. You have to ask yourself which one of your special triangles has a side of 2. Well, your 45, 45, 90 triangle does not have a side of 2. But your 30, 60, 90 triangle does. So to me, it makes total sense that we're going to draw a 60, 60, 60 triangle. And I know you guys are getting tired of me doing this all the time, but I really want you to see this, okay? So I draw my 60, 60, 60 triangle. I label my sides 2. I drop down a height here. I call this a 1. And this is 30 degrees, and this is 60 degrees. And so now using Pythagorean's theorem, then this side over here would be square root of 3. Okay, now what we're looking at is 2. Secant of an angle gives me 2 over 1. Secant of an angle gives me 2 over 1. Well, here's 2 and here's 1. Now what is secant? What is the ratio for secant? Well, secant is the reciprocal of cosine. Now cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. Okay? So let's be really careful here. I don't want to use 30 because if I use 30, this side over here is opposite and this is my hypotenuse. However, if I use 60, this is my adjacent side and this is my hypotenuse. So could I not say the secant of 60 is adjacent, is hypotenuse 2 over adjacent 1. There it is. And 2 over 1 here is the same thing as 2 over 1 here. So the secant of 60 is 2 over 1, or of course in radians, pi over 3. All right, number 23. Well, they've given us pi over 6, which is the same thing as 30 degrees. So I'm going to very quickly draw, I'm just going to go ahead and draw the 30, 60, 90. I think we've done the 60, 60, 60 enough. Here's 30, here's 60, here's 90, this is 2, this is 1, and this is square root of 3. I want you guys to be able to draw your 30, 60, 90 triangle that fast, okay? Just very, very quickly. Okay, the cosine of 30 degrees, here's 30. Cosine is adjacent over hypotenuse, so the cosine of 30, or the cosine of pi over 6, would be square root of 3 over 2. Moving on. Now, we're going to try to find the tangent of an angle that gives me 1. Now, this one's going to be a little more challenging because your 45, 45, 90 triangle 45, 45, 90 has a length of 1, a length of 1, and a hypotenuse of the square root of 2. Your 30, 60, 90 triangle has a length of 2, a length of 1, and the square root of 3. Now here's why it's tricky. We're trying to find an angle that when we take the tangent of it, we get 1. And notice both of these triangles have a side that has a 1. But here's the difference. Now watch this carefully. Tangent of an angle gives me 1 over 1. So I really need two sides that have a 1. And this triangle here does not have two sides. Okay, so I'm going to go with the other triangle. Right here. And now think about this. Tangent of whatever angle I choose to use is going to be opposite over adjacent, TOA, okay? Well, it really doesn't matter if I choose this angle or this angle because my opposite side is 1 and my adjacent side is 1. In other words, the tangent of 45 degrees is 1 over 1, which is 1. Okay, so the angle is 45 degrees, which would be the same thing as pi over 4. Okay, moving on to number 43 and 42. Now here's where we're going to use this table I gave you guys, okay? And this will be pretty simple. Actually, students will do this pretty quickly. I mean, we want to find an angle so that when we take the sine of it, we get 1/2. So here's sine, and here's 1/2. So the sine of 30 is 1/2. Now they want you to give your answer in degrees and radians, so your answer would be 30 degrees and pi over 6. Okay? Now, cosecant of theta gives you 2. So we're looking for an angle that when you take the cosecant of it, you get 2. So here's cosecant, and here's 2. So the cosecant of 30 is 2. So the answer would be 30 degrees, or you could also say pi over 6. Okay? Let's continue on. Okay, in number 45, we're saying when you take the secant of an angle, you get 2. So here's secant, here's 2, so the secant of 60. So the secant of 60 gives you 2, so 60 degrees, or in radians, that would be pi over 3. Okay, now, in the other problem here, part B, cotangent of an angle gives you 1. So here's cotangent right here, here's 1. So it looks like to me the cotangent of 45 would be 1. So your degrees would be 45 degrees, or in radians it would be pi over 4. Moving on to number 47. And here we go. All right, let's see here. First of all, we're looking for an angle that when we take the cosecant of it, we get 2 square root of 3 over 3. So here's cosecant. And here's 2 square root of 3 over 3, so it looks like we would use 60 degrees. So the answer would be 60 degrees, or you could also say pi over 3. Okay? Now for part B here, we're looking for an angle that when you take sine of it, you get square root of 2 over 2. So here's sine, here's square root of 2 over 2. So the sine of 45 degrees, or you could also say pi over 4. Okay? Moving on to the next problem. Okay, now we're getting into the word problems. And we are going to do 10 of these. They're going to be pretty tough, but if you'll take some really good notes and follow along, I think you'll be okay. All right, here we go. A 6-foot person walks from the base of a broadcasting tower directly toward the tip of the shadow cast by the tower. So let me give you advice right now. I'm going to put the sun in the sky right here. Here's the tower right here. And so it's casting a shadow this way. Now let me say something here, students. My advice to you is to just use lines and points, because straight lines and points make a lot nicer triangles than trying to draw a tower like this and then, you know, or a tree like this and stuff like that. Okay, I would just use lines and points. Okay, so here's your tower right here, and of course it's casting a shadow on the ground, so the sun's going to hit here and cast a shadow on the ground. I'll change colors here so you can see it. So here's the shadow on the ground, and we'll say the shadow kind of ends about right here. We don't care if it's drawn to scale. That's not a big deal. So here's your shadow right here on the ground. Okay, now let's continue on. A person who is 6 foot tall walks toward the tip of the shadow. So he starts here. Okay, here's your person right here, and he's walking this direction on the ground. Okay, And it says, hold on one second please, it says they walk toward the tip of the shadow. When the person is 132 feet from the tower and 3 feet from the tip of the shadow, the person's shadow starts to appear. So in other words, here's the line or the shadow where the person's head's going to hit, and his shadow will start appearing. So we're going to put him about right here. And again, don't get fancy and draw a person, just put a straight line, okay? And the person is 6 foot tall, and they're going to hit right here because they're just starting to form their own shadow over here. So we know from here to here is 132 feet. And of course my triangle is not drawn to scale, and that does not matter one bit. From here to here is 3 feet, okay? Part A, draw a right triangle that gives a visual representation of the problem. We've done that. Show the known quantities of the triangle and use a variable to indicate the height of the tower. Well, I think we've filled in everything very well here, and the height of the tower would be h. Okay, now use a trigonometric function to write an equation involving the unknown quantity. Now I want to pause here and say something, students. Look at part C. Please listen to me carefully. Look at part C. What is the height of the tower? Now if you'll think back to geometry class, you learn that whenever you have a triangle drawn and then you have a line drawn here that's parallel to this line here, this little triangle right here is similar or proportional to the big triangle here. Okay, so I want to say right off the bat, before we go any further in this problem, that I could definitely solve this problem a lot easier by going like this. Now don't take any notes, just watch. I could draw a really big triangle and put an H here and put 135 here, because 132 plus 3 is 135. Then I could draw a little triangle here and I could put a 6 here and a 3 here, and I could use proportions. I could say as H changes to 6, 135 changes to 3. And I could cross multiply and find H, and that'd be really easy. But unfortunately, if you'll look at part B does say that you have to use a trig equation. So we are going to use a trig function and write a trig equation to solve for H, unfortunately. Okay, so let me go ahead and do this. I want to slide this out of the way, and I want to draw a big triangle. Okay, and we're going to put H here, and I'm going to put 135 here. Okay, and then I'm going to draw a little triangle here, and I'm going to put a 6 here and a 3 here. Now listen to me carefully, students, please. Okay, in this big triangle right here, if I just knew what this angle was, let's pretend it was 30 degrees. Man, if I just knew what that angle was right there, I could solve for H so quickly. I mean, think about it. If this is 30, this is my opposite side, this is my adjacent. I could say tangent of 30 equals opposite over adjacent, if I just knew that angle. Okay, well, think about it. We don't know that angle, but using this triangle over here, we can solve for x. We can put an x here, and we can solve for that angle. If this is x, go straight across, and this is my opposite side. Okay, let me get a drink here real quick. And this 3 here is my adjacent side. So using tangent, I can say tangent of x equals opposite over adjacent. Now students, we learned just the other day on Friday to use your calculators when you're missing an angle. Remember? And I have it right here for you. Look, tangent of, I use theta, we'll call it x, that's fine. Tangent of x equals 6 over 3. Remember, you would hit second tangent, so on your calculator, tangent of -1 would pop up, then you would type in 2, or 6 divided by 3, and you will get 63.4 degrees. Okay, so let's go back here. Now we know this angle right here is 63.4, because this angle right here is 63.4, and they share the same angle. The little triangle and the big triangle share this angle right here. Okay, so with that in mind, now I can quickly set up my equation and solve for H. Here's the angle that I know, 63.4, so I go straight across. This is my opposite side, OPP. This is my adjacent side, ADJ. What trig function uses opposite and adjacent? Well, tangent does. So I can say tangent of 63.4 equals opposite over adjacent. There we go. And now your denominator is 135, so we're going to multiply both sides by 135. So 135 tangent 63.4. Now if I multiply the right side by 135, I'm just left with h right here. Okay? Now I have this already worked out for us over here. Here it is. 135 tangent 63.4 degrees equals 270. Okay, so if you type into your calculator 135 times tangent 63.4 degrees, you will get 270 degrees. So the answer to this right here is 270 feet equals h. So there, we found the height of this tower, 270 feet. Okay. All right, let's move on to the next problem, number 72. Now, in this problem here, nowhere does it say we have to use a trig function, so we're not going to. We're going to use proportions, okay? A 6-foot person standing 20 feet from a street light casts a 10-foot shadow. And they give you a figure, so we're going to use this figure, okay? What is the height of the street light? Now I'm going to copy this triangle, if I could please. So I'm going to come down, over, and then straight up. There we go. So I've copied that triangle. And let's see here real quick. Let's get this line right here. The guy's right here, so we'll put a line right there in the triangle. And now let's slide this out of the way. All right, there we go. So if you look at the picture here, I know from here to here is 20 feet, and from here to here is 10 feet, and I know the guy is 6 feet tall, and they want to know the height of the street light, okay? So remember what to do. We have a really big triangle that has a length of 30 right here, 20 plus 10, and a height of h. We have a little triangle that has a height of 6 and a length of 10 right here. So let's use proportions. Remember, if you have a triangle and inside that triangle you have a line drawn here that's parallel to this line here, these two triangles will be proportional or similar. You should remember that from geometry, okay? So you can say as h changes to 6, 30 changes to 10. Or you could reverse it and say 6 over h equals 10 over 30. Anyways, if you cross multiply, 6 times 30 is 180, and 10 times h is 10h. Now we'll divide both sides by 10, and 18 equals h, and we're dealing with feet, so the height of the lamp or the street light, excuse me, is 18 feet. All right, let me get a drink here, and we'll continue on. Number 73 sounds really difficult at first. It's actually one of the easiest ones we'll do today. It's very easy. Okay, so let's take a look here at number 73, and here's what it says. You have a 20-meter line that's used to tie a helium-filled balloon. Okay, students, I'm back. Sorry about that pause there. Okay, you got a 20-meter line that's used to tie a helium balloon down to the ground. Because of a freeze, or a breeze, excuse me, the line makes an angle of approximately 85 degrees with the ground. So I'm going to go ahead and try to get a little bit of room here. Here's the ground. Here's the balloon going up into the air, and here's the balloon here, and this would be 85 degrees. So obviously the wind is blowing this direction, okay? All right. Let's see what step A says. Draw a right triangle that gives a visual representation of the problem. So let me go ahead and draw this imaginary height coming down. And there's my right triangle, okay? Show the known quantities, so and then use a variable to indicate the height of the balloon. So we know the line is 20 meters long, so from here to here, that's the line holding on to the balloon. So we know that length right there is going to be 20 meters, okay? And then let's see, the height is right here, so here's my h, the height of the balloon. So there, we've done step A, we've drawn our right triangle, we've labeled everything. Moving on to letter B. Use a trig function to write an equation involving the unknown quantity and then find the height of the balloon. Well, this is pretty simple, students. It really is. Look, here's my angle that I know, 85 degrees. So go straight across. This is my opposite side. Here's my 90 degrees, so 20 is my hypotenuse. So I need to use a trig function that uses opposite and hypotenuse. What's going to be sine? I mean, we know the sine of 85 degrees is opposite over hypotenuse. And we do know how to solve these. Whatever the bottom of your fraction is, in this case it's 20, you multiply both sides by that number. So if I multiply the left side by 20, I have 20 sine 85. If I multiply the right side by 20, I get h. Okay? Now I have this worked out already for you right over here. So the 20 times the sine of 85 equals h. If you type this into your calculator right here, you'll get approximately 20 meters. Okay, so there. Let's go back a page. We have found the height. The height here is 20 meters, which, by the way, I know it's not exactly 20. Listen to me carefully, students, because a leg of a right triangle can never equal the hypotenuse. But students, if this was really 85 degrees right here, it would look like this. It would be almost straight up in the air. And so it's really, when I solved this right here, I probably got out something like 19.6 or 19.7 or 19.8. So I just rounded to this, which is totally acceptable. It's not a big deal. Okay, so that's totally fine with what we did there. So if you look at letter C, excuse me, we have totally found the height of the balloon. Now D says the breeze becomes stronger and the angle the balloon makes with the ground decreases. How would this affect the triangle you drew? Well, students, this is really simple. I mean, we should know this. If the breeze is blowing this way, like this, and it's pushing the balloon further and further this way, as it pushes the balloon, then obviously this angle is going to get smaller and smaller. As it pushes the balloon, if the balloon is held by this 20-meter line, the balloon's going to get circling lower and lower to the ground. As the breeze blows higher and higher, it's going to push this balloon forward, and this 20-meter line is going to pull it down to the ground. So obviously this 85 degrees is going to get smaller and smaller. Okay, and so that's what's going to happen. Now, as that happens, look at the rest of the problem. What they want us to do, and it sounds hard, but it's so easy and it's so quick, and I will allow you guys to just copy my answer down if you want to. They want us to complete this table, which shows the heights of the balloon as the angle decreases. So the harder and harder this wind blows, this 85 degrees right here becomes 80, and then 70, and then 60, and then 50, and then 40, then 30, then 20, then 10. That's a really strong wind, but I think you get the point. Okay, so I've already filled this in for you here. See this 85 right here, students? All you'd have to do is put an 80. So 20 times the sine of 80, and then put a 70, and then put a 60, and so on and so forth. Then put a 50, then put a 40, right down the line. And so I don't really think you need to spend a lot of time doing that. You know how to take your calculator and type in 20 sine 80, 20 sine 70, 20 sine 60, 20 sine 50. So if you just want to copy these, feel free to. Just make sure you understand what I've done, okay? And that is what would happen. And look at the height. The height was 20, then it drops to 18, then 17, then 15, then 12, then 10, then 6. And when the degree is 10 degrees like this, the height of the balloon is only going to be 3.5 feet off the ground, okay? And so that would take a pretty strong wind. But you can see as the angle right here, I'm going to call it angle X, as the angle decreased and got smaller and smaller, then the height also went down. So letter F is a pretty easy question. As the angle the balloon makes with the ground approaches 0, how will this affect the height of the balloon? Well, I mean, the height would be 0. As this angle right here gets lower and lower and eventually hits 0 degrees, then your height would be 0. So the answer would be your height would be 0 feet. And that of course would take an amazingly strong wind for that to happen, okay? All right, moving on to the next problem, number 74. A biologist wants to know the width W of a river in order to set instruments for studying the pollutants in the water. From point A, right here, let me change colors here so you can see it. From point A, the biologist walks downstream to this point right here, which is 100 feet. And from this siding, it's determined that theta is 54 degrees right here. over to point C. How wide is the river? Well, this is pretty cut and dried, pretty simple. Here's your angle right here. So this right here, this side right here would be called your adjacent side, okay? And this would be called your opposite side. So we need to use a trig function that has opposite and adjacent. Of course, that would be tangent. So the tangent of 54 degrees equals opposite over adjacent, so W over 100. Well, your denominator is 100, so we're going to multiply both sides by 100. So 100 times the tangent of 54 degrees equals W. And I've already got that worked out for you over here. If you type in 100 tangent 54, you will get 137.6 feet. Okay, so this width right here is 137.6 feet. Moving on to number 75. In travel, excuse me. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. So this angle right here is 3.5 degrees right here. Okay, now watch this carefully. After you drive 13 miles closer to the mountain, so look what they did. They said from here to here is 13 miles. Okay, now watch this carefully. The angle of elevation to the height of the mountain is 9 degrees, which makes sense. The closer you get to the mountain, the more you're going to have to look up into the sky to see the top of the mountain. So now the angle of elevation is 9 degrees. Okay, now they want you to approximate the height of the mountain. This is going to be really, really difficult to do. Let me show you how you have two different triangles. Now watch carefully, please, students. And really, we want to draw right triangles because we're dealing with trig functions, okay? So here's my first right triangle. Everybody see that okay? So I'm going to go ahead and copy that right here. In fact, I'm going to go like this and get a good copy of it right here. That's not a very good copy, but it will have to do, okay? So there we go. Now, here's my second triangle. I hope you guys see that. Here's my second right triangle, right here. Here, then straight down, then straight over, okay? So, excuse me, with that in mind, let's go ahead and get a copy of this triangle. There, there, and there. All right, that's a little better. And let's pull that triangle, nope, not that. Let's pull this triangle right here. And there we go. Now you'll see why I'm doing this in a second. I'm trying to help you see this, students, okay? All right, now let's label our triangles. We know this is 3.5 degrees. We know this is 13 miles, okay? We know this is 9 degrees. Actually, this is not 13 miles, and I apologize to you. That's totally incorrect. It's 13 from here to about here. Okay, so let's slide this over so we're going to get this labeled correctly here. And then we're going to say from here to here is x, which means from here to here is also x, because the distance from here's where the other line went up right here, okay, and here was your 9 degrees right here. So this distance right here is going to be called, hold on one second, is going to be called x, and this distance right here will also be called x. This is a really, really difficult problem, so please pay attention. Now this is your height right here, and this is your height right here, and they want us to find the height. Now I've copied everything down over here, so we're going to slide this problem out of the way, and we're going to go ahead and use these for the rest of our problem. Now watch carefully what I do. You should remember this from Algebra 2. Whenever you have two unknowns, you have to write two equations. Okay, that's just how it is. If you have three unknowns, then you need three equations. So we have two unknowns, okay? So we are going to have to write two equations. Now the first one here is this. If you'll look at your angle right here, I know the name of this side over here is opposite, and the name of this side here is adjacent, okay? So I have opposite and adjacent, so I'm going to use tangent. I'll see if this makes sense. I'm going to write tangent of 3.5 equals opposite over adjacent. And my adjacent would be what? 13 plus x. From here to here is 13, and from here to here is x. So 13 plus x. Now for this triangle here, here's my angle, 9 degrees. This is my opposite, and this is my adjacent. So I'm going to write tangent of 9 degrees equals opposite over adjacent. Now students, we're going to use the algebra principle called substitution. And so let me show you what I mean. I realize I have two unknowns over here, h and x, and two unknowns over here, h and x. However, watch this. If I multiply both sides of this equation here by x, I'll be left with x tangent 9. And if I multiply the right side by x, I'm left with h. So look what h equals. H equals x tangent of 9. So see this h right here? I can grab this h and get rid of it, and in place of it, I can put this right here. Now that's a pretty big help, okay guys? Now I can actually multiply both sides of my equation. Notice my unknown is an x and an x, so I can really solve this. It's going to take a little bit of work, but I can do this, okay? So I'm going to multiply the left side by 13 plus x, and I'm going to multiply this side here by 13 plus x. Now if I do that to the right side, these will cancel, and I'll be left with x tangent of 9 degrees. Over here, now be careful, you have a binomial, excuse me, a two-termer. Here's one term and here's one term times a one-termer. So you must take the 13 times tangent, so you will get 13 tangent 3.5, and then you must take the x times your tangent, so you'd have plus x tangent of 3.5. This is a really difficult problem. Now watch students, I want to solve for x. This term here does not have an x, but this term does, and this term does. So I need to get all of my terms that have an x on the same side. So I'm going to take this term right here, and I'm going to bring it over to the right side. Okay, so when I do that, it's going to look like this. It is a positive, but when I bring it over, it's going to become negative. So see if this makes sense. I'm left with 13 tangent 3.5 equals x tangent 9 degrees minus x tangent 3.5. It was a positive term. I brought it over here and it became a negative term. Now, Mr. Earhart, why would you do that? Well, because I'm solving for x, so I want to get all of my x terms on one side. So watch what I do next, students. Watch this carefully. Hopefully you've taken notes on all of this. Okay, you should have, so I really should be able to clear some of the space off here. Now, if I have all of my x terms on the same side, hopefully you remember this from Algebra 2, I can factor out an x over here like this. Pull an x out, and I'm left with the tangent of 9 minus the tangent of 3.5. Okay, and of course over here I still have 13 tangent 3.5. Now students, if I'm going to solve for x is being multiplied times this parentheses here, so I'm going to divide this side here by tangent of 9 minus the tangent of 3.5, and those will cancel, just leave me with x. But I must also divide this side by the same thing, so 13 tangent 3.5 divided by, and of course I'm not trying to be neat here, tangent of 9 minus tangent of 3.5. There we go. So I've already worked this out for you in the next page, and here it is right here. If you type in your calculator 13 tangent of 3.5, enter, and then divided by, and be sure and put parentheses around this, divided by tangent of 9 minus tangent of 3.5, you will get 8.8. Now remember, you're solving for the height. Okay, let's go back here. We're solving for the height. So even though you solve for x, and that's a great job, that's not your final answer. Now remember, in your notes, you should have written somewhere from the very beginning, you should have had here in your notes, let's see what this was. Give me just a second. It should have been, and I apologize, students, for not having this. Give me just a second here. We had, a triangle like this with 9 degrees here, we had an X here and an H here. So earlier we had written this. Do you remember this? We had sine of 9 equals opposite over adjacent. Well, look, students, now that we know X is 8.18, then right here for X, we can put 8.18. And that's what we did, okay? So right here is 8.18, and then next you would multiply both sides by 8.18, and if we did that correctly, this would be over here, and of course, over here on the right side, you'd be left with nothing but H, and then of course, H equals 8.18 times tangent of 9. So if you type this into your calculator right here, you will finally, after all of that, get the right answer. That might be the hardest problem we're doing today right there. That's a tough problem, okay? So the height of the mountain is 1.3 miles, okay? All right, let's continue on to the next problem. I'm going to get a drink here real quick. Okay, here we go. From a 40-foot observation tower on the coast, a Coast Guard officer sights a boat in difficulty. The angle of depression to the boat is 4 degrees. So here's your angle of depression right here. How far is the boat from the shoreline? Now, what we're looking at is this. Let's go ahead and draw just lines and points, okay? There we go. And then here's the shore coming out to the boat, all right? And then we have this right here. So listen to me carefully, students. When it says, how far is the boat from the shoreline, you're looking for this line right here. Okay, we're going to call this X. Now, please don't forget from geometry, when you have two parallel lines cut by a transversal, alternate interior angles are congruent. So this angle here, if it was 4 degrees right here, would be congruent to this angle right here. Do you remember that from geometry? When two parallel lines are cut by a transversal, alternate interior angles are congruent. So these two lines would be parallel. This is a horizontal line, and this is a horizontal line, and they're cut by this transversal right here. So if this is 4 degrees here, then this would be 4 degrees right here. Let me get rid of all these lines real quick. And so this would be 4 degrees. So look what you've got, students. You have I'm going to trace it for you. I'm going to cut it out. You've got a right triangle right here that goes down, and then over, and then up, and that's not a very good drawing, but you get the idea, okay? So here's my triangle, and if you'll look at the lighthouse here, this height is 40, this angle is 4 degrees, and we're looking for X. So we're home free, it's easy. Based on this angle here, this would be your adjacent side, and this would be your opposite side. So we have the tangent of 4 degrees equals opposite over adjacent. Now your denominator is X, so I'm going to multiply both sides by X. If I multiply the left side by X, I have X tangent of 4. If I multiply the right side by X, I'm left with 40. And now, in order to solve for X, I would have to divide both sides by tangent of 4. And if you do that correctly, you're going to be left with X equals 40 over the tangent of 4. And I have that right here for you. X equals 40 over the tangent of 4, and if you type this in your calculator, you will see the answer is 572 feet. Okay, not too difficult. Okay, number 77. A ramp of 20 feet in length rises to a loading platform that's 3.5 feet off the ground. Draw a right triangle that gives a visual representation of the problem, and then show the known quantities, and then use a variable to indicate the angle of elevation, or the elevation of the ramp. So here we go. This will be pretty simple. Here's my ramp going up to right here, and it says the ramp to a platform. The platform is 3 1/3 feet. Okay, and it says the length of the ramp is 20. So this is the actual ramp right here. So this is 20 feet. And we're looking for the angle of elevation right here, X. So really it's pretty simple. I mean, we're looking for this angle here. We have a right triangle. And so if this is the angle I'm dealing with, this would be the opposite side. This would be the hypotenuse. And so what trig function uses opposite and hypotenuse? Well, sine does. So I can very easily write the sine of angle X equals opposite 3 1/3 over my hypotenuse, which is 20. And now we did learn the other day that when you're looking for an angle using your calculator, you would hit second sine. And so I would hit second sine and up pops sine -1, and I would use some. You could put 3.3 if you wanted to. That's fine. 3 1/3 is 3.3 divided by 20. Enter, and if you hit that correctly, you're going to get 9.59 degrees. Okay, 9.59 degrees, and that is the angle of elevation for that ramp. Okay, moving on to number 78. This looks like a really hard problem, and it's really easy. Very, very simple. And here we go. A steel plate has the form of 1/4 of a circle with a radius of 60 centimeters, and two 2-centimeter holes are drilled in the plate, positioned as shown in the figure. Find the coordinates of each hole. Now, students, I'll be honest with you. This is a very fair question. I mean, all that you need is a little understanding of Algebra 1. If I told you to find this ordered pair right here, you would count over 5 and count up 3. So you'd go over 5 and up 3. So the name of this ordered pair would be 5, 3. Okay? Well, that's all that we're going to do here, students. I mean, they want us to find the coordinates of this hole right here. So all that I'm going to do is I'm going to go over until I'm equal with the hole, and then go down, and then draw a right triangle. It's that easy. Now, if I want to know how far over this point is, I have to go over, and that's my X. And if I want to find how high that point is, that's my Y. Isn't that easy? So all that I have is a right triangle that looks like this, and this is 30 degrees here, and this is X, and this is Y. And I can do this really quickly. And by the way, I know the hypotenuse because I know, look right here. It's on here for you, students. I'm going to erase this. Look right here. We know the distance from here to here has to be the same as the distance from here all the way to here. It's a radius. It's going to be circular, okay? So from here to here is 56. From here to here is 56. So I know this is 56. And now we're good to go. To find X, I would say the cosine of 30 equals adjacent over my hypotenuse. And to find Y, I would say the sine of 30 equals opposite over hypotenuse. Now watch carefully. There's a little trick to this you might not have thought of, so hold on and be careful. From now on, the rest of this year, when you're given the angles 30, 60, or 45, I expect you to use exact numbers because you know what the cosine of 30 is. We have a table for that, okay? And the table's right here, all right? And so I do expect you to use that table from now on when it's 30, 60, or 45. So I'm going to multiply both sides by 50, and I'm going to have 50 cosine of 30 equals X, okay? I'm going to multiply both sides by 56. I apologize. This will be 56. Sorry about that. And this will be 56. I'm going to multiply both sides by 56, and I would have 56 sine of 30 equals Y. Okay? Now come over here and look at what I've done. So 56 sine of 30 means 56 times the sine of 30. But students, we know the sine of 30 is 1/2. And 56 times 1/2 is 28. So there's your Y. That means the height right here is 28. All right. Now, 56 cosine of 30 equals X. Well, the cosine of 30, if you look at your table, is square root of 3 over 2. And if I take 56 over 1 times square root of 3 over 2, your 2 would cancel with your 56. 28 times, you're left with 28 square root of 3. I would not allow a decimal answer in a problem like this. Students, listen, from now on, when you're using 30, 60, or 45 degrees, I want exact numbers for your answer, not decimals, okay? So here's your X value right here, 28 square root of 3. So this would be 28 square root of 3. So what's this ordered pair right here? Well, you're over 28 square root of 3 and you're up 28. So your ordered pair would be 28 square root of 3, comma 28. All right, now let's go on to the next part of the problem. Now they want us to find the ordered pair for this point. Okay, no problem. Draw your triangle straight up and then draw it straight down. And there we go. We have another right triangle. Now, from here to here is 30 degrees. From here to here is 30. So the whole angle right here is 60. So I have a triangle that looks like this. Over, it comes up. This is 60. The hypotenuse is still 56. And this is my x. I go over so far, then I go up. And that's my y. So my two trig functions would be cosine of 60 equals adjacent over hypotenuse, and sine of 60 would equal opposite over 56. Multiply both sides by 56, and I have 56 cosine of 60 equals x. Over here, multiply both sides by 56, and I have 56 sine of 60 equals y. And now let's go ahead and solve this equation. And let's solve this equation once I've done that for you over here. Let me get a drink here real quick. Okay, if you'll look on your table, the sine of 60 is the square root of 3 over 2. So I have 56 times square root of 3 over 2. Put this over 1, 2 would go into 56, 28 times. 28 times the square root of 3 is 28 square root of 3. And now I have 56 cosine of 60. The cosine of 60 is 1/2. Look on your table, you'll see that. And 56 times 1/2 is 28. So 28 equals x. There we go. So that means I went over 28 and I went up 28 square root of 3. So the ordered pair would be over 28, up 28 square root of 3. So 28 comma 28 square root of 3. Really not, I mean, it's a tedious problem, but I didn't feel like it was that difficult to figure out, okay? All right, number 79. This one looks really hard, but it's really not if you'll just think about what they're saying, okay? A tapered shaft has a diameter of 5 centimeters. So from here straight down to here is 5 centimeters. This is a hard problem to understand, but once I explain it to you, I think you'll get it, okay? Let's see. And it is 15 centimeters long. So from here all the way across is 15. Of course, that's what it says right here, okay? So basically what they're saying so far is this, students, this opening here is going to be, I believe, larger than this one here, okay? Because it's tapering down and there's a little bit of a lip right here, okay? Now, if you'll look, there's a real small right triangle, and it starts here and it comes up like this, okay? And it hits right here and it comes straight down, and then we come across this dotted line right here. So you have a real small right triangle that looks like this. Okay? And actually, I do that a little backwards. Let me fix this real quick. It would be, let's see. Okay, students, sorry about that. Just doing a little quick check to make sure I was accurate. It's going to come straight across and then obviously straight down. So the triangle comes straight across and then straight down. So there's your right triangle right here. And then this angle will come down like this. All right? And we're going to call this 3 degrees. Now remember, if the total length across here is 15, the total length across the top would also be 15. Okay? 15 centimeters. Okay, students, I'm back. I apologize about that break there. I'm really having a hard time visualizing. I want you to have confidence in me as a teacher, but I'm really having a difficult time seeing this picture here. And I think I have this backwards again. I apologize to you, but it is difficult to see what they're drawing. But the more I look at this, it is, and on a test or a quiz, I would make sure I made this very obvious, but it's going straight across here, running parallel to this side down here, okay? And I apologize for getting that confused, all the way across and then straight up like that. I know it's not easy to see, and it kind of confused me too, but that is what it looks like. So the triangle would really look like this. It'd be straight across, and I'm going to draw it a little bigger than it is so we have a little more room to work with, and then it comes up and then over like this. Now it's not super easy to see, but that is correct, okay? This would be 3 degrees here, and if this length down here is 15, then this would also be 15 here, and we're trying to find the diameter D of this entire shaft over here, okay, all the way across. Now we do know from here, students, to here, we know that's 5 already, okay? So do keep that in mind, okay? Let me get a different color of ink here real quick. From this point here to this point here, going down, we do know that is a measurement of 5, because from here to here is also 5. Okay, we do know that. If we can just find this little, we'll put a little X right here. If we can find this X right here, that little bit right there, which of course would then be the same down here, then we can find this entire diameter going across. Okay, so now that we have the triangle hopefully drawn correctly, if this is our angle here, 3 degrees, we know this is our opposite side here, and this is our adjacent side, so we can say the tangent of 3 degrees equals opposite over adjacent, and then multiply both sides by 15, and we would have 15 tangent of 3 equals x, okay? Which is what I have right over here. 15 times tangent of 3 equals x. If you type this into your calculator right here, you will get 0.786. Let's go back here to a picture. This little x right here, this little distance from here to here is 0.786, which means the little distance from here to here down here is also going to be 0.786. So the whole diameter is going to be 5 plus 0.786 plus 0.786. So your answer would be right here, 5 plus 0.786 plus 0.786 equals 6.57 centimeters. So the entire diameter would be 6.57 centimeters. Okay, hope that made sense. Let's go ahead and continue on to our last problem here. Okay, students, number 80 will be very similar to the one we did back here, where we had a quarter circle like this, and we found an ordered pair. Okay, let's go ahead and take a look at it here real quick. Use a compass to sketch a quarter of a circle with a radius of 10 centimeters. So here's our quarter circle. I'll go ahead and draw this. I'm going to try to draw it for you decently well. Let's see if I can do that. Here's our quarter of a circle. Something like this. Okay, and that's definitely not what we're looking for. So let's just go like this and kind of sketch it on my own here. Alright, there's our quarter of a circle. There we go. Okay, and it says the radius would be 10, so we know this is a length of 10, this is a length of 10. And then it says construct an angle of 20 degrees in standard position, so we're just going to kind of estimate this here to be 20 degrees. Okay, so there's my point. And we're going to put 20 degrees here, and then it says drop a perpendicular from this point of intersection here, let's see, down to the terminal side. So we'll go down like this. Alright, there we go, and put a right angle right there. Now we know this here would also be 10 because it's a radius, and so we know, actually now I'm going to go ahead and get rid of this 10 right here. I did not make a mistake. This was 10 earlier when I had the length going from here all the way out to here. Okay, but that's no longer the case. Now we're dealing with this triangle right here, from here up to here and down and then over. Okay, so if the radius is 10, then this line also here is a radius. It would be 10 also. Okay, now let's see what else we're doing. It says calculate the coordinates of x, y. So we're going to find the coordinates right here, x, comma, y. Okay, in other words, we're going to find the x going over and the y going up. And then after we do that, we're going to use this right triangle to find all 6 trig functions, which really isn't a big deal. We might not do all 6, but the main thing we want to do here is find x and y. And really, students, if you'll look, I mean, I'm going to erase everything here. All that we have is a red right triangle, and that's all that we need. I mean, we don't need anything else. I mean, that's it. So I'm going to go like this. I'm going to try to grab this right here and not do that. There we go. And then do this. And that's it, students. I mean, we're really totally good to go. There's my triangle. So to find x, I would say cosine of 20 is adjacent over hypotenuse, and to find my y, I would say sine of 20 equals opposite over hypotenuse, multiply both sides by 10. I would have 10 cosine of 20 equals x. Multiply both sides by 10. 10 sine of 20 equals y. And then if you look at the next page here, I've already worked these out for you. X would be 9.397. So X right here would be 9.937. And then, or 3.97. So we'll fix that very quickly. 9.397, and then y would be 10 times the sine of 20 would be 3.42 for y. So y right here would be 3.42. And then the directions ask us, using the right triangle right there, they ask us to go ahead and find all 6 trig functions. Now I'm not going to do that in students. I mean, that's just a lot of time, and if you want to, you were asked to do that, but it's really basic math. Now we know how to do this. I mean, a sine of 20 would be what? 3.42 over 10. And then type into a calculator and divide it out. The cosine of 20 would be adjacent over hypotenuse. The tangent of 20 would be 3.42 over 9.37. The cosecant of 20 would be hypotenuse over opposite, so 10 over 3.42, and then divide that out with your calculator. We're not going to take time and do all those, but that is what you would do to finish the problem. The main thing was getting this triangle right here totally and completely solved. Okay, these are definitely tough problems. I feel your pain. I know they're not easy, but they're definitely part of pre-cal. So I hope this has been a help to you. Contact me, call or email if you have any questions.